welcome to CEE 117 or Statics of Rigid Bodies. Today we are going to discuss Lecture 4. So, in Lecture 4, the first topic is equivalence of vectors. So, physical quantities of vectors are classified as follows. Okay, so these are the different classification of vectors. First, we have the fixed vectors. So they are vectors having the same magnitude, direction, and point of application. So, for example, we have vector A and vector B. So they are equivalent in nature since they have the same magnitude of 20 units as well as the same point of application point 1. So if they both have the same magnitude, direction, and point of application, then they are fixed vectors. Next, we have the sliding vectors. So what do we mean by sliding vectors? So these vectors having the same magnitude, direction, and line of action. So for example, guys, we have this vector A na ang line of action niya is towards the point. Okay. And then, what if meron ding vector B? So, ang vector B, the same magnitude, and they also have the same line of action. So, ito yung line of action ng vectors. Okay, so along this line of action, dyan mag-occur ang dalawang vectors. Okay, so if ganyan, then they are called sliding vectors. Okay, next, we have the free vectors. So, free vectors, if they only have the same magnitude and direction. So, vector A and vector B both are free vectors because they have the same magnitude and direction only. So, not the same point of application and not the same line of action. Not the same of line of action kasi, di ba, yung vector A, dito siya, ito yung line of action niya. And vector B is dito. So, hindi sila same of line of action. So, they are just free vectors. Okay. Next, we discuss the principle of transmissibility. So, the principle of transmissibility is very important in our understanding sa statics. So, what is this principle of transmissibility? So, this states that a force may be moved anywhere along its line of action without changing its external effects on a rigid body. So, ibig sabihin guys, as long as the same line of action, we can move the vector or the force. Okay, example, we have this vector, right? And then, applied siya right here. And then, what if i-move mo itong vector? Dalhin mo siya dito. Okay lang, no problem at all because of principle of transmissibility. Kasi, sa kanyang pag-transfer here, nag-occur man din yan sa same line of action. Kung dito mo ilagay ang 20 units, hindi pwede. Okay? Okay, again. Kung dito mo ilagay ang 20 units na vector, hindi pwede kasi, not the same line of action sa original ko. So, ibig sabihin, kahit saan mo ilagay yung vector, okay lang, basta ang paglalagyan mo is the same line of action. For example, dalhin mo dito yung 20 units na vector, okay lang, kasi ang line of action nito is the same sa original. Okay, so ang principle of transmissibility, pag transfer lang yan. Okay, you can transfer the force, the vector, as long as along the line of action lang. Okay, ito yung line of action ha, or path of the vector. Okay, next. Let's have reduction of concurrent force systems. So, the single equivalent force is the resultant R, which is the vector sum of all the concurrent forces. So, ibig sabihin, madami kang forces, kaya lang gusto mo siya i-reduce into one vector only or one resultant. So, we call that resultant, the single equivalent force. So, na-discuss na ni before, wherein the resultant is just the sum, vector sum of all concurrent forces. Okay, take note guys, when we say concurrent, they have the same origin. Okay, so the components of resultant can also be calculated using scalar equation. So, kung ayaw mo mag-vector sum, yung i-add mo yung I, J, at saka K, respectively, pwede ka din mag-scalar solution lang. Basta, tandaan lang na Rx is summation Fx, Ry is summation Fy, Rz is summation Fz. Okay, let's have an example. Using the given figure shown, calculate the magnitude and direction of the resultant of the three concurrent forces acting at point A. So as you can see, there are three concurrent. Meaning sa concurrent, they have the same origin. 'Di ba? F1, F2, and F3, they have the same origin at A. So, if you want just to reduce it, kanang isa lang siya, gusto mo, ayaw mo nitong tatlo, gusto mo isa lang talaga, what we call the resultant. So, ano gawin natin? So, since, 'di ba, these are all inclined forces, F1 and F2, so we have to reduce it into its component. So, kunin natin ang component. Again, guys, if you are confronted by this kind of problem, get the resultant, calculate the magnitude and direction of the resultant. So, ang gawin natin is kunin natin ang components ng kada force. Okay? So, two axis lang man yan, x and y. 2D lang ni siya na problem. Okay, so let's have the solution. 'Di ba ito man yung original na problem or figure? So, ang gawin natin, we get the components. So, let's start sa F1. So, ang F1, dito padulong, 'di ba? So, ano ang components ng F1? May components sa y-axis, may components sa x-axis. So, yun. How about F2? Ang F2 naman, dito siya. Right? So, anong components niya? Positive y-axis, F2y. Ang component niya sa x-axis is negative kasi to the left man, di ba? Pag ganito yung arrow, left ang isa, and then pasaka ang isa. Okay. And then, ang F3 naman, just vertical. So, wala siyang Fx. Naglay lang siya along the y-axis. So, let's solve each of the following. So, first, let's start with F1y. So, ang F1y is the vertical component of 50. So, guys, pag makita kayo ng slope dito, hindi angle, so, ang first gawin nyo is kunin nyo yung hypotenuse. So, anong hypotenuse ng slope dito? 4 vertical, 3 horizontal. So, 5. Bakit 5? Kasi 5 is equal to 3 squared plus 4 squared. Diba? Pythagorean theorem, trigo. Okay. So, therefore, kung isolve natin ang vertical component ni F1, so that's 50 na force times vertical component. Ano ang vertical component niya? 4. Tingnan nyo ang vertical value. Vertical value is 4 over hypotenuse square root of 3 squared plus 4 squared. So, that is 40 Newton. Now, let's compute the horizontal component of F1. So, ang horizontal component niya is katong force, 50, times ang horizontal. Ang horizontal value, 3 over Hypotenuse, square root of 3 squared plus 4 squared. So, the answer is 30. So, F1 pa lang yan. How about sa F2? So, ano yung F2? Ito yung F2. Tingnan natin ang F2, di ba? Ito yung F2. So, what are the components? Yung naka-violet. So, ang vertical component niya is F2y, positive. So, F2y is, value ng F2y is 10, isign mo yung angle. 10 sine of 60. So, the answer is 5 square root of 3. And then, ang horizontal component naman niya, to the left, di ba? Ito yung violet na arrow. To the left, so, F2x is, lagyan natin negative 10, cosine of 60 is negative 5. And then, ang vertical component naman ng F3, yung naka-green, so, pababa man. So, negative yan. Negative 60 sine of 90. Bakit sine of 90? Kasi ang angle ni F3 with respect to x-axis is right angle man na siya, 90 degrees, diba? So, sine 90 is negative 60. So, F3x, negative 60 cosine, sine of negative 60 cosine o sine of 0 is 0. Okay, so therefore walang horizontal component si F3. Okay, so ito lang yung present na mga components. So ano gawin natin next? Ang gawin natin next is i-combine natin ang mga like terms. So, unahin muna natin ang y component ng resultant. 'Di ba ang resultant is summation of fx and fy and fz. So, this is the x component of the resultant. This is the y component of the resultant. It's the z component of the resultant. So, unahin muna natin si ry. So, i-add lang natin lahat ng mga fy. So, ang lalabas, negative 11.34 Newton. So, ano yung mga ry? Fy, ito, at saka ito. Okay, next. Rx naman, summation of fx, where right forces are positive. Okay, so, itong ibig sabihin ha, right forces are positive. Ito, upward forces are positive. So, for Rx, tingnan natin lahat ng mga x. Ito at saka ito. So, 30 minus 5 plus 0. So, that's 25 Newton. Therefore, pag ilagay na natin yung resultant, that's equivalent to 25i minus 11.34j. So, ang x, di ba, is I. So, yun ang katabi ng I is x, which is 25. Katabi ng j is negative 11.34. Okay, so this is Rx and this is Ry. Okay. Next, how about the direction? So, of course, guys, always ang direction, tan theta is equal to Ry over Rx lang yan siya ha, pag 2D. So, therefore, the direction of the resultant is negative 24.4 degrees. Kung i-drawing natin yan, ito yung resultant natin. Dito siya mag-occur sa fourth quadrant, right? And then, ang kanyang angle with respect to the x-axis or the horizontal is 24.4 degrees clockwise. Kasi negative, 'di ba? Pag negative yung angle, clockwise ang rotation. Okay. Clockwise from the positive x-axis. So, we have the magnitude, 27.5. By the way, how did we get 27.5? di ba vector ang ating answer dito? So, makuha natin ang kanyang scalar magnitude pag naka 25 squared plus negative 11.34 squared. So, the answer should be around 27.5 Newton. So, the resultant is 27.5 Newton at 24.4 degrees clockwise from the positive x-axis. Okay, next. 3 ropes are attached to the post at A, as shown in the given figure. So, meron tayong tatlong ropes or PC or anything na string, and then nakakonect siya dito. And then nakatie siya from this Let's call this point D. So, this is B, this is point C, this is point A at point D. Okay. The forces in the ropes are F1 equal to 260 pounds, F2 equal to 75 pounds, and F3 equal to 60 pounds. So, calculate first the magnitude of the force R that is equivalent to the three forces. So, what is the equivalent of the three forces? We call that R or the resultant. Okay? Basta naa gani mga equivalent, resultant na siya. So, let's find that. And letter B naman, the coordinates of the point where the line of action of R intersects the YZ plane. So, if makuha na natin ang resultant, saan daw mag-intersect ang resultant sa YZ plane? Saan ang YZ plane? That is the plane defined by Y and Z. Oh. So, ito yung YZ plane ha. Why is it YZ plane? Kasi this is the plane defined by Y and Z. Alright, so let's answer muna letter A. So, determine the coordinates of the points where the forces pass. So, the first step para ma-answer na to ang letter A is kailangan natin kunin ang coordinates kung saan pupunta ang mga or saan mag-act yung mga forces. For example, si F1, saan man nag-act si F1? Tingnan niyo si F1, ano ang line of action niya? Point A going to point B, right? F2, ang F2, nag-act siya from point A to point C. Si F3 naman, nag-act siya from point A to point D. So, first step, always determine the coordinates of the points where the forces pass. So, kunin natin yung mga coordinates ng kada points. So, point A, ano ang coordinates ng point A? So, dapat master na natin to. X value 3, tama? Y is 12, the Z is 0. Bakit siya 3 ang X? Kasi 'di ba 3 parallel to x-axis, 3 parallel to y-axis, 12 parallel to z-axis, wala kasi sa origin siya 0. How about B? Point B, no x, 0 ang x, 0 ang y, positive 4. How about point C? Point C, dito man banda, 0 ang x, 12 ang y, and 4 ang z. Ang D naman, 3 ang x, y is 0, z is 0. So, define muna natin yung mga coordinates para mas madali na lang later. And then, next step, calculate the rectangular representation of vector force F or the forces. So, di ba, naka-scalar lang man ni siya, no? So, para ma-vector na to siya, kailangan natin ng scalar value multiplied by the unit vector. So, kailangan natin itong unit vector. Okay, let's start with AB or F1. F1, ang F1, tingnan natin, di ba F1 acts from A to B. So, therefore, para ma-vector form si F1, F1 is equal to scalar magnitude F1 multiplied by unit vector AB. So, bakit AB? Kasi, yun man yung direction ni F1. Nag-act man siya from A to B. So, dapat AB din ang points mo na ilagay dito. Hindi pwede mag-interchange. Kasi maiba na yung answer. So, ang scalar value ni F1 is 260 pounds. Multiplied natin yan sa unit vector kung saan siya nag-act. Diba ang unit vector again is A to B, si F1. So, tingnan natin yung, hindi pwede mag-interchange ito ha na B to A. So, ang origin sa F1, ang tail niya is nasa A. Ang head ng arrow padulong sa B. So, AB dapat na, dili na pwede BA. Okay, how do we solve this one? Ito, di ba? So, initial A, final B. So, dapat ang pag-minus-minus natin, final minus initial. So, para sa x, unahin natin ang xb minus xa. And then, I. Next is yb minus ya para sa j. And then, zb minus za. Okay, and then, square root natin yung mga answer sa parentheses. So, therefore, ang vector representation ni force 1 or ni F1 is negative 60I minus 240J plus 80K pounds. So, for you to make sure kung tama ba jud, then get the scalar magnitude of this one. Dapat mag-equal na siya sa 260. Dapat pag-solve nimo ani equal to 260 para tama jud ni siya. Okay, next, how about F2? F2 naman, para makuha yung vector representation niya, yung kanyang scalar magnitude, F2, multiply natin yan sa kanyang unit vector. Ano yung unit vector ni F2? Saan pala siya nag-act? Nag-act siya from A to C. So, dapat ang points dire, that's A to C. Hindi pwede mag-interchange kasi ang original position is A, final position is C. Okay, scalar magnitude ni F2, that's 75. Multiplied natin yan sa unit vector. Ano ang unit vector AC? Again, final ang C, initial ang A. So, una dito, mauna ang X component ni C minus X component ni A and I plus Y component ni C minus Y component ni A. J plus Z component ni C minus Z component ni A, K. And then, butang lang dire kung ano yung answer sa kada parenthesis, butang lang. And then, we can have the vector representation of F2 equal to negative 45I plus 60K. Alright, what's next? Ang F3 na naman. So, for F3, of course, ang vector representation niya is the scalar magnitude of F3 multiplied by the unit vector acting from A to D. So, di ba nga nung AD? Kasi di ba tingnan natin, F3 acts from A to D. So, dapat AD po na ang points dara. So, let's have it. Scalar magnitude ni F3 is 60 pounds multiplied by the unit vector. Ito yung unit vector. So, ang first na value here, this is x component ni D minus x component ni A, I plus y component ni D minus y component ni A, J plus z component ni Y minus, z component ni D minus z component ni A. Okay, and then, simplify, we can have F3 equal to negative 60J. Isa-isa na siya ha. So, 0 man ni. So, 0 din ito. So, ang mabilin, negative 60J. Okay, so, natapos na natin ang second step wherein ginawa nating rectangular representation ang lahat ng forces. Kibali, ginawa nating vector form lahat ng forces. Okay. Next, step. Calculate the resultant by adding the I, J, K respectively. Of course, Diba? Ang first question is, what is the magnitude of the resultant of the three forces? So, meron naman tayong vector form nila. So, ang gawin na lang natin is, i-add na lang natin ang I, J, K respectively. Diba? From the previous slide, resultant is equal to F1 plus F2 plus F3. Oh, F1 plus F2 plus F3. So, naka-vector form yan lahat. So, i-add lang natin respectively ang I, combine J, and then combine K. So, therefore, the resultant now is negative 105I minus 300J plus 140K. So, that's the vector form of the resultant. How about the scalar form of the resultant? Ano ang magnitude nito? Magnitude niyan sa scalar is negative 105 squared plus negative 300 squared plus 140 squared. So, the answer should be around 347.31. So, that's the resultant, magnitude of the resultant, pounds. Okay, yun. Nakuha na natin. Alright, next.